All right, so I see some of us are back. Let me share my screen
Yes, sir.
again. Right, let me share my screen. Let me know once it's visible.
Yes, sir, your screen is
Yes, sir.
visible.
It's visible. Yes, it is.
All right, so now we are going to look at the host firewall. In Windows, it is easier that we click on the firewall or searches for the Windows firewall and then we create the rules there. In Linux, it is, I would say, simple, but not as straightforward as it looks like in Windows. And it's like the other things as well, the same user experience. But it is far more capable than the Windows firewall, is what I would say. So what happens is in a firewall of Linux or Unix, which is IP tables. Some people call it as an IP chains as well. And I'll tell you why it is called as IP chains or IP tables. See what happened. We have input, we have output, and we have forward. So these are three by default labels which are available in IP table or a firewall. Input is something which is inward traffic. Output is for an outbound traffic. And forward is where my internal inbound traffic is getting forwarded to local or for private network, basically. Okay. So I have these input, output, and the forward. These are the three labels or the chains that we have. Now, input, output, and forward, all these three can have rules. This can have a rule, this can have a rule, and this can have a rule. When we start building these rules, it creates a table for us, and that's where we call it as an IP table. Because it's a chain of rules, people call it as an IP chains. Okay, so that's the concept behind this. Now, what happened? From a IP rules or IP tables perspective, or let's say from a rules standpoint, you can have certain actions. So you can have actions which can be accept, which can be a drop, and which can be a reject. Difference, so accept is like allow. Drop and reject are denial. Only differences in drop, the sender would not have an acknowledgement or an information about what has happened to the packet. Whether that packet was rejected, whether that communication happened, didn't happen. So drop would not send back any acknowledgement or a rejection information of that packet. Whereas in a reject, that acknowledgement is sent back that, for example, this port is closed, you're not supposed to communicate on this. So that thing will happen in reject. In drop, no conversation. Reject, drop means drop. So you will have these actions common again. Then before actions, I would say you can define certain protocols, like it is a TCP or ICMP or UDP. So you can, or whatever, so you can define those protocols, which means the inbound traffic or a inward traffic is for which protocol you are accepting, dropping, or rejecting. So you can have the rules on the protocols. Now, while we talk about a protocol, there is a source and destination information. It can be an IP, it can be a port, it can be what else? Yeah, I think that's it. So we will have an IP or a port from a source and destination information. And same thing will go on these areas as well. Right? Then other than this, you can also control some of the state information because it's a stateful inspection of the packet that you do with IP table. So you can have a stateful inspection done as well with the inbound and outbound. So stateful inspection can be done. States can be new. It can be established. Right? So you can do a stateful inspection for inbound and let's say for outbound as well. Now, from because it's a firewall, you can also limit the rate from a DDoS standpoint. Let's say if you have to limit something, you can limit that rate or that information or that packet burst, for example, you can limit those things as well. Right now, how to create a rule? So rules are simple. You start with IP tables. Again, just remember you have to do it with sudo or with the super user. So IP tables, first of all, you say append. So append into which chain or which rule you need to append. So either you can use -a or you can use -- append, whatever you prefer. You can use either of it. You say IP tables -a or append and then say input, which means you are creating a rule for input chain. Okay. Then you say, let's say a protocol is TCP. So you are saying input chain protocol I'm focusing is on TCP, and where let's say the destination port that you are monitoring a traffic on is a port 22, which is a SSH port. So I am looking at TCP 22 port and I am either jumping to accept or drop or reject. So if I create this rule, it says on the input chain, look for TCP port 22 and take a decision whether to accept, drop or reject. If I take this rule a little ahead, I can say destination port is 22, but my source, for example, the source IP is 192.168.1, let's say .100, and I'll say accept, and I'll say R, or I'll leave it like this, and I'll say drop. Now, since this rule is coming first, if my communication on port 22 is happening from this IP address, the communication will go through. Rest everybody which is coming from this particular network would be denied access. Okay. I can also be explicit in saying this like this as well. So this is also fine, which means all the entire IP space minus the 100, everything will be dropped. Only this person would be allowed access, or this IP would be allowed access. Now, taking it a little ahead, what I can do is, so let's make it A. So taking this a little ahead, what I can do is I can do a M state, which is modify or monitor, not modify, monitor the state. And I'm saying state, rather I'll put it here. And this and I'll say hyphen as this hyphen m state hyphen state is let's say new, then accept, which means this IP can initiate a connection to my system on port 22. Now I can further modify it with the limit as well. So let's say on this hyphen m state and limit, I can use both together. So state new, and then I can limit the rate per hour. So, or per minute, let's say. So I will say 20 connections or 20 packets per minute. And my limit burst, which means after this, it'll start to reject, is 100 or 50, let's say. So this way, I am using the protocol. I'm using the source and destination information. I'm using a stateful inspection. I'm using the limit or a throttling as well. And I'm deciding on my actions. Clear? Now, I take it as a yes, by the way. So now, if I look at this, the changes are happening on the input chain, which means it's an inward traffic, incoming traffic to the server from a client. If I have to create a rule which should not allow a connection from going outward from the server as a new connection, I can say IP tables hyphen a output. Destination can be anything, source can be anything, but state is new hyphen j drop, which means if there is any TCP connection with a state of new and obviously with hyphen m state, uh, so state new, take the action of drop. Whereas if it is established, then accept. Clear?
Yes, sir. So the first output rule will say like if it's a new connection, drop it. If it's already learned connection, establish or
Yes.
something. Okay.
Yes. Because I don't expect my server to initiate a connection outside. I expect a client to initiate a connection to my server, but not the other way around.
Okay. Got it, sir.
Yeah. So that's how you will manage the IP tables. Now in a forward rule, you say the source is this and the destination is this. Allow. If the source is this, destination is something else, deny, which means your system is acting as a router when then you can have the forward rules created, or when your system is like a load balancer, then you can have those rules configured, or when your system is forwarding any request to, let's say, or your system is acting as a middleware, then you can use these forward rules as well. Okay. Now, when we do append, when we say hyphen A, it basically goes at the end of the IP table because it's an append operation. If I have to insert at a specific level, for example, then I will have to kind of do it a insert operation rather than the append operation, which means I will have to insert at a specific line, right? So what I'll do, I'll say IP tables and then hyphen insert or hyphen I, whatever is comfortable. input or output, you can define that. So let's say I am inputting it or I am inserting at an input chain. Then I will have to define the rule spec or the rule number. So if I do, let's say IP tables hyphen L, nothing right now is there, but I will have certain rules here. So I can do an insert after the rule, or I can just specify the rule specification and insert after that. So let's say insert input 10. That's my rule number. And then start with your rule. So this rule, whatever you have specified here, for example, except, will go at a rule number 10. So it will go and insert there. To list, I can use IP tables hyphen L, not loops, L. To flush, which means to completely finish everything, the rules that I've created, I can use IP tables hyphen F. If I have to restart my system, there are certain rules which are in the memory, which means I have not saved it. I can simply say IP tables save, and that will save my rules. Or in some of the systems, it is a single command, IP tables hyphen save. So this is something that I can service IP table saves. So in this is how I can save the rules as well for my IP tables. Clear?
Yes, sir. Clear with those.
Right. Now, when we do a remote logging, we will have to enable a rule or let's say create a rule so that my logs can be transported to the another server. So I can say IP tables hyphen A output because it's an outbound operation that I'm performing, hyphen P TCP, that's a rather UDP. Now, when I'm saying a port number, I can say a D port or hyphen D port, or I can say destination port as well. And 514 is what my UDP port would be for the remote logs. So destination port 514. Then I can specify the destination as well so that it only goes to a specific IP. So I can say hyphen D 192.168.1 dot, let's say 50 is what my remote log server would look like. So I can say hyphen D, the IP address, and then hyphen J, except. So that will allow the transportation of my logs to the remote server whose IP would be this. Clear? Simple?
Yes, sir. Sir, I have a doubt. So,
Yeah,
this is like the IP tables entry. What we enter here will apply the host-based firewall rule to the Linux systems, no?
correct.
Okay. So we have to define both inbound and outbound outbound connections.
Yeah.
Okay.
So I have a doubt, sir.
Yes.
So let's say we have any security group or firewall wherein we allow all traffic,
Hmm.
and we configure this IP tables where we restrict the port 22 for certain IPs. So
Hmm.
in that sense, what happens is any outside traffic that comes in. So for example, let's say in firewall we've given any to any, and any outcoming traffic that comes into the server. So firewall will allow that traffic when it reaches this server, and since we have configured these IP tables where only certain IPs can access the port 22. So at that point of time, that traffic would be blocked, right? Unless and until if that IP is whitelisted. Okay.
Correct.
So respect of whatever the firewall that we define, whatever values or other rules that we define within this IP tables would come into precedence.
Yes. Only for that particular server.
Yeah. Okay.
Sir, usually like where we see this more in real, like does a proxy server uses this one, or a SAP web dispatcher uses this one, or where it is mainly implemented, sir? Because like most of the antivirus or the agent based protection host based protection services will have this default enabled, no? So like where exactly this will come into picture, or it's in the IAS server for Windows or for a web
So,
servers?
so I'll tell you, there are a couple of scenarios where I have seen it in practical. So there was a situation in one of the ITITS company. Some of you are working for that company as well, by the way. So this company is based in Noida, headquartered rather in Noida, and they have offices across all over India. Now, this company had a situation where they were going for a PCI compliance. Now, since their IT systems are scattered and they have a requirement where a particular server should only belong to a particular customer. So if it's a healthcare customer, they would have a kind of a designated systems for that healthcare customer, but sitting out of a common network. So they had a challenge in segregating the network at a granular level, and they didn't wanted to do that as well because of the efforts and the amount that they would spend on the firewalls and hardwares and stuff. So they wanted a solution wherein they can achieve the compliance of the customer and of the PCI as well. And that's where they decided to go with the host-based firewalls, where they can create a rule that only specific set of IP addresses can access the service or the data from the server. That way, even if they are operating out of a common network of 100 servers, only 10 were allowed, because in a one VLAN you can't have multiple firewalls. I mean, you technically can have, but it's not cost effective. So they had the servers in one common VLAN, but at a server layer, they segmented the servers with the rest of the servers by configuring the local firewalls of the OS. That's one case scenario that I am talking about. The other scenario is in one of the payment processor is what I've witnessed. They again were in the same situation where they have a common pool of network on the hosted on the cloud. It's a common network, and within that common network, everything is allowed as a traffic. Now, what they have done, they brought in this firewall, the IP tables. They brought this in, configured it so that their payment switch, their HSM, their web gateway, all of these devices can talk to each other, but not the rest of the servers, which are yet production, but doesn't have to do anything with these servers. So you can have those segmentations created within the common network and work it out. The other area is you can put it on a internet facing services, be it any of the service, you can have it configured on the internet or a public facing infrastructure as well, where you are allowing only one port, let's say Apache port or an IIS port, you are allowing only one port from an outside access and nothing else. Even if the services are running, you are only allowing port 80 for the entire world, and port 22, let's say from a specific fixed IPs only you are allowing it. So two services are open, but one is IP bound and one is for the entire whole world. So that way you can utilize these host-based firewalls.
Okay. Sir, when you take up from the audit perspective, no, so which files you will refer for to check this host-based firewalls?
So in Unix, I can simply dump IP tables -L, and that will give me all the rules.
Okay.
Okay. So IP tables, we have three chains: input, forward, output. Accept, drop, reject are the actions. Hyphen, append, or -A, both will work for appending a chain. Insert or -I would work for insertion. Chain, rule number, and the rule specification we have to provide. Similarly, for the deletion, we can use -delete, the rule number or the rule specification. And if we just have to check whether my rule is correct or not, I can simply run it with IP tables -check, and then let's say input, output, forward, whatever. So I can put that chain name. These are the sample rules that we have. -A input, -P ICMP, which is for the ping, ICMP type, echo request, drop. Input chain, protocol TCP, destination port 22, accept. Input chain source is this particular network, drop. Input chain TCP port, destination port is SSH. I can give the number as well. Hyphen source IP is this, then drop. Input chain port is protocol is TCP, destination port is SSH, source is this, and the state is new and established, accept. Again, output chain port is protocol is TCP, source port is 22, which means my outbound connection has initiated from a port 22, which is a TCP SSH port. So if the source port is 22, destination is this, then established state, then accept. Here input protocol TCP, destination port is this, limit the rate, limit the burst, accept. Block scan, again, a different chain that I can create, customized one. So -A block scan, TCP flags can be SYN, ACK, FIN, RST. -M limit, then limit is 1 per second. If it breaches, then return. Return is basically the reject. So this way I can create and manage the IP table rules. Listing down all the rules, IP tables -L, -F for flush, has been IP table, sorry, service IP table save will save my existing rules on the disk. And IP table save also would work on the Debian based architecture or the Unix operating systems. So that will also work. Clear? I'll take that as yes. The next thing is the system CTL parameters. In Windows, we do not have this functionality, and this is something which is, sorry, unique to the Unix world, where we can control how our system would behave in a normal production environment and what are some of the areas which we can tune. The list is very big. Some are related to performance, some are related to security, and some are related to the experience or the overall system configuration, the way the system behaves. If I have to see the parameters which are configurable, I can run sysctl-a command, and that will dump all the parameters which can be configured. If I have to tune the parameter, I can just say sysctl-w to write a parameter, and I'll say a parameter name and a parameter value without the space between equals. So parameter equal value without space. Now, some of the parameters that we have listed down here: net, IP version 4, IP forwarding. So we are not allowing the IPs to be forwarded, which means that my system is not a proxy server or a forwarder server or a load balancer. If I am a proxy or a load balancer, I will probably put it as 1. Do not accept source routing, which means whatever routes which are available to you as a server, use those routes and do not accept the routing information coming from elsewhere. Then kernel.sys request, that's for the debugging function of the kernel. So if there is a debug request or a system request, whether I have to debug it or not, that I can control. Then from a attack standpoint or from a security of or hardening of a system standpoint, what I can do is I can say net IP4 SYN cookies equals to 1, which is to protect the SYN cookies, and the SYN ACK retries is limited to 5. So I can control the SYN flood attack by setting these parameters. If I am not intending my server to work as a router, I can disable certain parameters like IPv4.conf all.send redirects, or accept redirects or secure redirects. I can essentially turn those off, which will disallow my system to act as an intermediary or a router. Similarly, accept redirects and secure redirects we have talked about. Then from a echo standpoint or a timestamp request standpoint, I can ignore those requests as well, so that which time zone my server belongs, people should not know about it. Otherwise, they can make some sophisticated attempts to target me when I am not working. So I have to ignore those broadcasts. So that's one. Again, SYN cookies is something which we have looked at earlier, is to disable the SYN flood attack. Reboot after kernel panic is yes, and that's configured as 10. That's the panic level that it'll boot or do a reboot after the kernel panic. Bad ICMP headers is to be ignored. Yes. Increase system IP port limits. So 2000 to 65,000 is my local port range that I have configured. So these are some, I would say, very few parameters which are available. But these are important one from a security standpoint of the IT machine. And that is where it is important to know about it. Now, once you have configured the parameter and you restart your system, the parameters would basically go back to the default or the reset values. So if I have to make a persistent change, I can configure the sysctl.conf file, and I can use sysctl-p for immediate parsing of the rules as well. So the moment I do changes, it stays in the memory or the RAM of a human being. Whenever we say sysctl.conf, whenever we added those files, then my changes would be persistent across my reboots as well. Okay, any questions on this?
Sir, can you just explain about that send redirects if router, but this is just server? It's not clear that part.
Correct. Correct. So it's like, so let's say if my system is a router, or my server is a router or is acting as a proxy or an intermediary server whose purpose is to accept the traffic and then take a decision to route the traffic to the appropriate destination, which is the work of a load balancer, let's say, or that's a work of my intermediary or a kind of middleware server as well. Till the time I'm not doing any such function, I would prefer to disallow or unconfigure the redirects. So what happened in your redirect messages, I will have an IP table internally. So I will get a request for a particular IP. I will look up to my table and I'll say, okay, this IP belongs to this gate or this house or this particular port, then I can move that particular request to that IP or that port. Now, until or unless I do this, by default, it is, I think, off only now. Earlier days, it used to be on, but until or unless I need this functionality, I would prefer to keep it off. So except redirects, I would not prefer. And at the same time, be it a secure redirect, I don't care. I don't allow any of the redirects to happen. Sorry.
So this is like the load balancing action, right?
Yes. So either on a load balancer or let's say on your Tomcat server as well.
Okay, so either of them.
Yeah.
Okay, thank you.
Okay. Then we'll come to NFS. Now what happened, and this is something which I have used very heavily when I was in the system administration in 2007 to 2010. And in fact, this is still being used in multiple data centers where there is a Unix heavy environment. And the architecture that I worked on the NFS was a little different, where we had, let's say, 10 web servers. Each web server would have a common shared drive or a common partition, and rest of the 9 servers would mount that partition as well. So it's like a mesh that we had across those 10 servers. So all those 10 servers would have a NFS running, which is a shared file system on Unix environment. So we will have that shared drive created on Unix, and that shared drive would be mounted by rest of the 9 servers as well, so that the data is available across the 10 servers. So that was the intention. Now, this NFS is a very old method, I would say, of sharing the information over the network, and specifically in the Unix world, where we don't have the graphical, or we didn't had the graphical flexibility at that time. So we had the network file system, which was created as an option to share the files across the network. And it is very simple to configure as well. And trust me, it's actually very simple to configure. Now, there is a file which is etc exports, and this file will have all the configuration or the mapping of my shares available on the server. So if I am kind of sharing something from my machine, that information would be available in the etc exports. What does that means is, just give me a second, connecting my laptop to the power. Okay. So what that means is that I will have a functionality to share everything on my machine with the rest of the world. So if I, for example, look at etc exports, right now it is empty. There is nothing into it, right? But let's say I want to share a TMP directory, which is here. So what I can do is vi etc exports. It's a blank file right now. Simple structure. I want to share TMP as with the rest of the world. So everybody who can reach out to my network would be able to see what is available as a share. So that's where this star comes in handy, which is a wild card. And I want to allow a read and write operation on the TMP directory, which means it's a share permission. something that we see in Windows as well. We have the NTFS permissions and then we have the share permissions as well. This is a share permission. So I have configured it to export TMP with everybody as a read write operation. And I will save this file. Now, once I have saved this file, I have to export my directories or my shares. So I can say export FS and -A that will start exporting or start broadcasting my share information on my local network. If I have to see what all I am exporting, I can just say -V, and this is what I am exporting. If you see, we didn't give all of this into our configuration. Star we gave, that is why it is rest of the world. So world is denoted as a star. TMP is something that we shared. We chose RW, but we didn't had a root squash, no all squash, no subtree check, security is equal to system. All that stuff we didn't give when we were configuring it, which means these are the default options. Now, sync is to basically make sure when we are having the data open or the drive opened across different sessions, the sync happens regularly, right? So that's the intention of having a sync. Then we have a W delay, which is the write delay. This is to ensure that we don't do too much of IO operation on the drive over the network. So we will have something in the buffer and then we'll push it after some time to the disk. Hide means I will basically hide this network. I will not announce this network on the systems which are not part of my local subnet or a network. They can still see it, but at a face of it, they would not get to see it. No subtree check is where I don't have to check for what is under TMP, what is exported, what is not exported, what is a permission, what is not permission. So no subtree check allows me to bypass that, and that kind of helps as well. Otherwise, it takes too much of a time to load that information and process the NFS as well. Then I have a security is equals to system, which means that my permissions, my rules that I have configured on the disk would still be available and would not be left up to the configurations that we have done here. Then RW is something that we gave read and write. I can allow only read only, so I can say RO. Then I have a root squash and no all squash as well, right? What root squash means is, see, from a root perspective, if I mount something or if there is a file which is created with 0 user ID, root squash basically remaps the user ID of 0 to the anonymous user with no privileges, which means it's a no user and no group. So if I say root squash, everything which is of root gets mapped to a anonymous user. This means that the root is stripped of all the privileges and will not be able to read any file which are not world readable or writable by the NFS, right? Which means that even if my root loads this on the system, on the machine, they would still not be able to perform the root operation on the device or the drive. So that's the root squash. And no all squash means rest all the user IDs would work as it is. So that's no all squash. Okay. Now, if I have to unexport, -A is for export. -v is to see what is being exported. And if I have to do an unexport, I can use -u. If I have to re-export, I can just say -r and that will re-export all the directories that I have available. If I have to see what are the different exports available on the remote server, which is not on this server, but a server on which NFS is running and which is running the service and is exporting something. So I can use show mount -e command as well. Let me just see if it works on localhost as well or not. Okay, so okay. So that is inactive. So let me start. Now, if I say this, I can see that export list for localhost because I have given localhost. But if it would have been on the remote server or the IP, I would see export list for the IP, and this is how the details look like. A TMP shared with rest of the world. So I would be able to see that. Now, if I have to mount it, I can simply say mount the IP of the server where it is available. Then a /TMP is shown here. So I'll say /TMP is something from a local or that particular IP I will have to mount and where I will have to mount. So let's say this. Now, if I see a local host TMP, 30 gigs of size is mounted on my this. So it's a remote mounting that I have done. Correct? Now, if I have to do unmount, it's simple. That's a U mount operation. Clear? Let me just open this for you to consume and absorb this as well. Are we good with this?
Yeah. Yes.
Simple, right?
What kind of attacks can we expect here? Because all of this would be within a network.
So typically the attacks would happen. See, now the NFS service is also available on Windows, which means that you can use Linux subsystem on Windows to see the exports available on the NFS server. And you can then make an attempt to discover what all servers are available, from what IPs they are kind of exposed to or allowed. And then you can potentially try to change the IP or kind of masquerade your IP during the conversation and try to mount that. That's one attack that you can do. The second attack is where you have the directories which are world readable or world writable. You would be making an attempt to download or mount those drives and then putting your malwares on top of it. So that so from the attacker's point of view, you would obviously need some place to position your malware. And these world readable, writable directories can be one area where obviously you would be little sensitized or sensitive about.
Yeah.
Then comes another service, which is for the same purpose of the sharing. It is called Samba. It is not influenced by Sholay movie, so don't take it on the name of Samba. But yeah, it's a very old service again. Nothing new, which is available in the modern operating system. It has been there since decades now. The configuration file for this is in etc again, because that's the preferred location that we have. So etc amba, and then we'll have smb.conf. Now this smb.conf is a file where you have all the configuration in terms of the host name that you want to set, in terms of the device that you want to export to, or also in terms of what kind of capabilities your shares would have, what user authentication you want to provide. Do you want to integrate it with an Active Directory or LDAP server for the user authentication? So all that configuration you can do it on this particular file. So let me open this. So if you look at this, you will have a view in terms of what the work group looks like. So you have a work group of Samba here. It's just a name, so you can have it like a home network, you can have it like a corporate network, a Reva network, whatever name that you want to give to this work group. That's what you can have it. Then a security is equals to user, which means that it's a user-based security device or a share. So it is not following the Active Directory or a directory-based authentication, but rather it is a user-based authentication which is being followed. Password database is uh, TDB-SAM, which is maintained by the SMB itself or the Samba itself. For for printing, you have a cups service on Unix, which is a print server that you can configure. So for printing, use cups. Again, this is all printer options. Then we have three shares created here. The share one is home, second share is printers, and the third share is a hidden or an administrative, which is a print dollar. Now this homes has a comment, which is a home directories. Valid users are these. I'll come to these strings or these symbols as well in terms of what this valid users looks like. Then browsable, yes or no. So whether this particular device is browsable or this share is browsable by the users, or somebody who knows this would be able to mount it. So yes and no of the device. Then read only, again yes or no, and inherit ACLs, yes or no, which means that whatever ACL which is configured on the hard disk for that particular folder, whether we are going to inherit that ACL or not, that we control from here. Now, if you look at other folders as well, you have a path variable defined, which means what path on the disk you are sharing. So path is equals to where TMP, for example, here is what I'm sharing. I will be able to create a mask as well here. Mask means from 644, what needs to be negated. So that's my create mask, which means any file that I will create on this share would basically be a 044, right? So that's the permission would look like. Similarly, if you go on the next share, you will see a write list, which is a print admin root. So that is there. And force group is print admin, which means anything that we will create on this will have a group of print admin. At the rate means it's a local group which is available. So that will be there. So once I have this configuration, the moment I will browse my Samba, from a browser perspective, when I browse it, I will be able to see all these prints or all these shares available to me. And that's where I will be able to click, move, write, read, whatever I want to do the operation. I will be able to do that on this device or this share as well. Now, coming to Samba again, what kind of attacks you can expect is the same that you expect the attacks to be there on the Windows platform as well, wherein the Windows, if the shares are exported, you would make an attempt to kind of exploit those share permissions, see whether you can access those or not, see who all can access the particular share. So all that uh, attacks that you prefer to do it on a Windows, you would prefer to do it here as well. So that's the level of the security that you will get here. It's the same as Windows. So that's what you will do, right? Now, again, from a Samba perspective, it is not advisable to have Samba on the production environment. The reason is it opens up the SMB port. And once it opens up the SMB port, the SMB itself is vulnerable to a malware transitioning or kind of movement within the network. So you don't prefer to do that. So hence, Samba as a server share services is not something which is preferable. Now, other things that you can configure. So you can have the log file size split per machine. So if I am accessing a particular Samba share from my machine, my log file will be created on the server. So I can have that maximum size of the log file. I can specify that. I can have a security as user, share, or server so that I can define my password database. I want it to be an Active Directory or the local database. I can define that. Similarly, I can have my Samba server added to a Active Directory as well with a domain member server. So I can set security is equals to domain, and I will be able to join that domain as well. So all these parameters is something that you can configure. Now, let's say you want to make this Samba server as a user authentication server. You can do that as well. You can set it as a domain master, yes, domain logons, yes, and the logon script as whatever if you have a batch script if you want to run. And password DB backup backend is something you can use it as TDB SAM, or you can have it integrated with the another Active Directory, which is on the LDAP SAM. These are some of the share level permissions that you can configure. Guest login, public share, read only, shared path, valid users as U1, U2 or GRP. Again, valid users as this, use of systems ACLs, yes or no, inherit ownership, yes or no, different log file, all that you can configure. Once you give a a user permission to access a particular share, a user password is not the same as the authentication password of the user. You can have a separate password for Samba and separate password for a system authentication. So you can use SMB password -a username to give the password to access the share. SMB client, similar to the way that you connect to the remote shares, you connect it and then mount it with the CIFS file system. You connect and mount the file systems remotely from a Samba perspective as well. I'll take a pause to see if you have any doubts or queries into it. Yeah, very good. No questions. Then we'll come to center. Yeah, sorry.
Would you also be configuring Samba, like practicals or
I
something?
can configure Samba, but I would not be able to showcase you because I don't have a GUI stuff with me. But I can do that really quick. So I have, let's say, sme.conf. A group I can say as race. Security, I'll take it as user. Pass DB backend is this. Printing, I don't need. I'll probably make it as commented. I don't need the print drivers to be there. Then I want to define a share. So share one is what my share name would be. Comment, I would say as testing of Samba services. Then I have some users onto it. So I have race one and race two. So I will say valid users is equals to race one, race two. These are the valid users. Browsable. Yes, they can browse it. Read only. No. Then inherit ACLs. Yes. Path is /emp is what I want to share. That's it. So this is what my configuration looks like. Anything else that I want to configure? Guest, okay, no, read only, no, path, invalid user, valid user, all that is okay. Log file is something that probably I would prefer as well. Percentage H, H would basically be a host stuff. I can do it as a machine so that I can get the IP. So that's it. And yes. So now my Samba smb.conf is configured with the parameters that I wanted till this side. Now what I have to do is I have to restart the Samba service. And once it is exported, I will have to connect to a remote share by the means of this. So I'll say SMB. Okay. Status. SMPD service is not found. I don't think that I have the Samba installed onto this. Okay. Yes, sir. Now, it's just there. Restart my service. Now I have my service started. So something is not right. Global parameter log file found. Okay, it's running only. Fair enough. It was coming in red, so I thought something went wrong, but I think it's fine. So now what I can do is I can use my SMB client to look up to my Samba services or the Samba shares. So SMB client, if I do this, I should be able to mount it. What was my share name? Share one. So SMB client. This, I have to install that as well. I have the SMB client and let's say local host share one. So now it's asking me for the password, which obviously I don't have. So I have to give the -u and then race one. Now it'll ask me for the race one's password. So root's password I don't have. Now, since race one password also I don't have from a shares perspective. So what I'll do, I will have to set the password for the race one by using the smb password command. So I'll do smb password -a race one, new smb password. Now, if I do this, I will be able to get the list of the shares. So I have a share one, server is localhost. If it would have been a remote share or the remote server, I would probably got a IP address here. I can use help to look at the different uh, stuff here. Normal L would list down the content of the share there. So it's like a access that I'm doing it. If it would have been a GUI interface, it's like a normal click that you can do. So you can then access the share remotely by mounting it up as well. Now in this particular client, what I am using is a SMB client. I have not mounted it on my machine. I am using it as a normal SMB client utility to emulate amount of a share using the user race one. And that's what I'm doing it, which is limited in a functionality. Now, if I have to look at it from a complete mount perspective, I can use this mount command, wherein O username is equal to U1, I would use a race one. Then the path, what I need to mount and where I need to mount. So if I use this command, I will be able to mount my SMB share as well, similar to the way that we have done on the NFS. Clear?
Yeah.
All right, we'll take a 15 minutes break and then we'll be back by 3:30.
Yes.
All right. Are we back?
Yes, sir.
Yeah.
All
Yes.
right. Let me share my screen. Okay. So remote centralized logging. Again, like everything, this is simple yet complicated. So, oops, sorry. So, see, why we do a remote logging is basically for multiple reasons. A, for a management, it becomes easier for us to keep a watch on what is happening in our environment at a centralized place. So rather than logging into 10 different or 100 different servers or machines, I would be able to better monitor my environment looking at one console and seeing what is happening in my network. So that is one benefit that I get. Second benefit, I would be able to create rules centrally, one effort, and that will tell me which system is infected, where the issue is going, and what is happening. So I will be able to take faster decisions and actions from a remediation standpoint or from a control or a containment standpoint. So that's a second benefit that I get. The third benefit from a perspective of a forensics is we will have a place of centralized logs across all the systems, all the machines. And if we start to back up those logs as well, I will have a better place to examine the logs that are collected over the tens or hundreds of machines. So that's another third benefit that I get. Now, in Unix, we have a package called as rsyslog, and this package allows us to remotely send the syslog or the system logs to the targeted or the destined centralized server. For local service, we have syslog. For remote, it's a new package which is called rsyslog. It's just an upgrade. Now, what happened when we do a rsyslog, essentially it is based on a TCP and a UDP. So I will be able to manage my logs on both the protocol. Then it also, you can specify multiple destinations, multiple hosts for the message delivery so that you can replicate the messages across 2, 3, n number of servers. So you can have a copy of message being sent across to different states or different log files as well. Then from a precision standpoint, you will be able to filter messages. You want to send only the information message, only the error messages, only the warning messages, or all of the messages. So you can define your own filters and have those filters act upon the logs being sent across. The other features is it allows for the TLS encryption. So which means the data in transit or the log in transit can be encrypted using the TLS encryption as well. And additionally, rather than a file or a disk-based log storage, you can have the logs stored in the SQL databases as well, wherein you will be able to run or fetch the logs based on SQL commands. So that's the benefit of rsyslog. Now there are different log files which we should be aware about irrespective of whether it's a RSS log or not a RSS log, but generally from a logging perspective, certain files that we need to be aware about. One is a kern.log or the messages file. This file basically contains the messages in terms of the Linux kernel internal operations. So be it a firewall, be it a routing information, be it a natting decision, all that action which is happening at a kernel level where the kernel is involved, we will have those messages stored or those logs stored in a kern.log file and var log messages file. Then we have a varlog WTMP and UTMP files as well. The difference between WTMP and UTMP is that WTMP holds the historical user data, while the UTMP holds the current user data. And that is where if you look at the directory structure, WTMP is under log and UTMP is under a runtime environment, and that's where in a run UTMP folder structure. So you have these two log files from a last log perspective. You can also look at the failed attempts by using a BTMP files as well. If there's any user authentication failure, you would be able to notice that as well. Now, if I, for example, look at last, these are my last user sessions that I have run on this machine, which means either my authentication, my reboot, all that actions are getting stored in this particular log file. This log file is what my WTMP. I can use my BTMP as well, or my UTMP as last -f, let's say UTMP or var log BTMP. And I don't have any unsuccessful attempts. Similarly, if I look at my UTMP, so this is what my current session information looks like. If I look at my WTMP, this is what is my historical data looks like. And that's the information which is stored from an user authentication standpoint. Similarly, I have a last log, which is the information about the last time that the users logged into the system, similar to what we have in a WTMP. But WTMP and last log both are binary files, so you can't open the files with the native VI viewer kind of a utility. Then I have a audit.log file, which is stored under var log audit and then audit.log. This is a text file with the audit D daemon. So daemon is nothing but the service that we call in Unix, and it holds my audit information that I have set on the objects or on the services. So based on that, my audit logs will be stored in this file. Now, in order to configure the RSys log, likewise, we will have a etc file, which is rsyslog.conf. There are different type of logs that we can configure, which we can send across to the target systems or system or a server. So, for example, we have a auth.log, which or auth type of log, which allows me to have messages which are login related or user authentication related or authorization related as well. So that's the auth messages. Then auth priv is where my authorization system works and kicks in predominantly for the privileged users. So that will go in the auth priv. Cron, my scheduling messages. Daemon, my services. FTP is like FTP. Kern for my kernel, LPR for printer, mail for email or mails, mark for the timestamp message, news for the NNTP kind of a protocol. RSys log is the internal log service messages. User is something which we echo, which we type a command and we get the message echoed back on the screen. So those are user. And then local 0 to local 7 is which is something can be used by the applications or the utilities. So that's my local 0 to local 7. Now, if I have to create a kind of the filters, I can, so these are the type of logs and these are the filters that we have. What we see on the right is the filter. So for example, none is like disable, debug only debug. So auth.debug, authpriv.debug. So those are like filters. Then info, notice, warning, error, critical, alert, emergency. These are all the different levels or the filters that we have, which we can use. Okay. Now, from a remote logging perspective, etc rsyslog.conf is the file where on the server, what we have to do is we will have to, so on the server and on the client, there are two systems involved. The, the server is the one which is running the rsyslog as a service. The client is the one server which is going to send the logs to the server. So these are the uh, two things that we have basically from a client and from the server standpoint, or the roles basically. Now on the client side, what we will have to do, we will have to enable the IAM TCP or IAM UDP, either of the module. So let me just show it on the screen probably. So I will have different modules that I can use. So for example, IAM UDP and IAM TCP. These are two modules that I can transmit my logs upon. I would prefer a TCP in an environment where the log generation is not very extensive. It is moderate. I will use TCP because it's a reliable protocol. But where my log generation is very, very extensive, it's like every seconds I'm generating tons and tons of logs rather than TCP because it can clog my network. I would prefer to go with the UDP service. So though it is unreliable compared to TCP, but overall it would be able to give me a better performance and the results than the TCP logging. Earlier, it was only UDP which was used. Now, with the modernization of the services, TCP has also been enabled for decent number of years. So now I have an option to change the ports as well if I wish to, but I have to make sure that on my server system, these ports are enabled as well and are listening for the RSS log. So I will have these modules enabled. Then what I'll do, I'll go, these are what my filters and my rules looks like in terms of star.info, mail.none, authpriv.none, cron.none being stored in varlog messages. Similarly, local 7.star goes into boot.log. Similarly, any emergency message goes onto the user screen itself. Cron, any kind of message, be it info, be it error, be it critical, emergency, anything goes into a varlog cron file. So if I have to look at what kind of logs are getting stored in which file, I can look into this and I will be able to get to know what kind of logs are getting stored in this. So these are the rules for my local logging. Now, if I have to do a logging from a perspective of my forwarding rule, there are two actions that I need to take, or rather one action rather, is, so this is what my server is. So I have not enabled my remote logging here, but this is what my server is. So let's look at the server part first. So what I am doing is I am creating a template where I am saying a log file is this, which means for all the hosts which are sending the log files to me, this is the variable which I am creating, a log file with a path and a variable of that log file. So this is just a definition of my variable. It has still not executed that variable. Okay. Now, when I say star.star hyphen question mark log file, this hyphen question mark means execute. So it stands for an execution. So the moment I say hyphen question mark, it executes my log file, which means all the logs which are being received by this server execute this variable. This variable will execute this particular file, which means at a server end, I will have to define a template to store the logs in a structured format. If I don't store it this way, what happens? Any log that is coming remotely will go into these respective log files and will get merged with the local logs as well. So I can do a merging, or I can define a specific log file for the systems. So that I can do. Till now it is clear. I take it as yes. Now let's say if it is a client system, so I would not have these two lines on the client machines. Rather, what I will have is on this section, which is begin forwarding rule. On this particular section, I will create an action to forward the rule, or rather to forward the messages to the target system. How would I do that? I would simply unmask or uncomment this line, which says star.star. I can use these filters as well, by the way. So I can say cron.star or authpref.star, depending upon what messages I want to send where. So I would say here it is all the messages. So star.star. Double at the rate means I'm using a TCP based logging. So my target server is a TCP reception. If I put a single at the rate, it means it's a UDP reception. So I would say send all the messages on the TCP reception to this IP or the host name on port 514. So that's the only thing that I will have to do it on my client. On the server end, I don't have to forward any messages to anywhere. I will have to define the template if I wish to, and then execute that template. That's it. So once I do this, I will have my data or my log executed and saved structured in a structured way on the centralized server. So if I look at here, so module load IMTCP, input type IMTCP, port number 514. I can have UDP here and here as well. If I wish to restart the syslog service, then on some of the implementation, you will have this kind of a rule. In some kind of an implementation, like we just saw, it will be simple rule like this. So both will work. So if you want to do it simply, this is the way. If you want it to be more techie, you can define an action wherein you are creating a forward rule, file name, maximum disk space, save on shutdown, linked list, resume retrack round, all that stuff you can define, target and port and protocol. So you can define this way as well. I prefer to make it simple, and that is where I simply say these are my messages going to 514 port on a remote host on a TCP reception. As simple as it can be. Clear?
So 514 is just a random port that you've defined here. Is it?
No, so 514 is a standard port, like 22 TCP is a standard port for SSH. Similarly, 514 is a port which is dedicated to the remote logging.
For remote log, okay.
Yeah, we can change this port, but by default, 514 is the port.
And I mean, so let's say we have about 100 servers, and all the logs of these 100 servers should be pointed to one server. So
Correct.
is the approach like we should have a dedicated log server for this purpose, or how is it?
Yes. So typically what you will do, you can have 3 copies of messages going across. So for example, here, what you can do is like star.star @ server 1 514. Just repeat this with another server as well, which is in another network, not in the same network zone. So server 2, and then probably as a backup or a DR server, you will have it as a server or a DR server 3. Right, so your logs, all the logs will go to these 3 servers. So if one is not there, you will have a copy of log on the second. If second is also not there, you will have a copy on the DR server. If DR server is also not there, thank you for the services.
But how frequently will these logs, I mean, do we define any cron job that has like,
No, so it will happen on a kind of near real time, I would say, not 100% real time, but near real time. So it will automatically be pushed.
oh, okay.
Clear?
Yeah.
Yeah. Now that kind of completes the Linux portion of it. We still have a Windows portion of it, which we will probably do in the next session.
Okay, sir. So the next sessions will be like 1 or 2 sessions will be there for Windows, sir.
One session only. See, in Linux, it's more of a concept building plus the commands learning, plus it's more of a command line. So it takes time to get a hang of it. When it comes to Windows, it is largely GUI based, and it's next. So it doesn't take too much of a time because the concept is already developed, right? So here we are just reapplying those concepts. So it should not take too much of a time. For example, VeraCrypt is like a GUI. So it just 10-15 probably minutes for us to practice. Same goes with the BitLocker, for example. Even if we have to do a management of a BitLocker from a command line, it would not take too much of a time because we are already aware about the concept of the disk encryption. So that way it should be easier and should be a straightforward one. So I think, in my opinion, one session should be good enough.
Okay, sir.
So what about assignment?
So there is no assignment, there is directly assessment.
Sir, so after the next class, it will be like a direct exam then.
Correct.
Okay.
Will it be online or offline, sir?
It will be online. So there will be some MCQs, and there will be a practicals as well. Practicals, I can tell you, whatever we have learned in Linux, if you can practice that out, those will be helpful. And whatever we are going to look at in Windows, it'll be very direct that way. So the questions would not be tricky. It's just that if you have practiced whatever we have seen in the sessions, if you have practiced it, you will be good with the practicals as well.
Okay, sir.
So will there be any
And
lab separately during the exam, or do we have to take?
Sorry?
Will there be any lab machine during the exam, or do we have to take any screenshots and put it like that?
So you will have to prepare a report, and I don't prefer a specific format. You can have it in Word, you can have it in PPT, you can have it typed on the notepad as well, whatever is preferred. But what I expect is when I read a report, I should get a clarity in terms of what you have done and why you have done. So if you are able to demonstrate that in whatever way and format, I am good. You can record a video and post it online. That's perfectly fine as well. But then it has to be something which I can understand, because I don't know too much of the stuff here. So I am relying on you guys to teach me. So the moment you do something, if you're able to record it and demonstrate it to me, I would be good enough.
Okay. Thank you, sir.
All right, guys, then I will close the session because I have a flight to catch in the late evening. But enjoy the rest of the evening. Enjoy your weekend. Don't screw it up. Spend time with your family as well. But then see you around in the next session. It'll be late night for me, but we'll still do it. So next session then.
Sure, sir.
Sir, hope you have a safe journey, sir.
Have a
Have a
safe
safe journey.
travel.
Thank you. Thank you so much.
Thank you, sir.
Thank you, Paris.
Thank you.
Thank you. Bye-bye.
Bye bye.
Bye.
Thank you, sir. Bye bye.